Okay, question 32 of the Blacktown Boys 2020 trial. A window in a chapel has been damaged by a storm and needs to be replaced. It is in the shape of a rectangle surmounted by a semicircle as shown. Let the radius of the semicircle be r meters and the height of the rectangle be h meters. Given that the perimeter of the window is to be 16 pi meters, show that h is equal to 8 pi minus r minus half pi r. Okay, so we know that the perimeter is 16 pi. And in order for us to work out this, we can see that we've got half a circle, so half of 2 pi r, half of 2 pi r, plus we've got our height, another height, and then 2 lots of r. So we've got 2h plus 2r. 2h plus 2r. So 16 pi is equal to pi r plus 2h plus 2r. So we want to show that h is equal to all of this. So I need h by itself. So I've got 2h is equal to 16 pi minus pi r minus 2r. So the height is equal to, we're going to divide everything by half, 8 pi minus half pi r minus r. Question B. Hence, show that the area A of the window is given by the formula A is equal to 16 pi r minus 2r squared minus half pi r squared. So the area of the window, we know, is half of pi r squared for the circle, plus 2rh for the rectangle. Okay, because this is 2r. 2r times h, that gives us the area of the rectangle. Except we know that h is actually 8 pi minus r. 8 pi minus r minus half pi r. So what does that give us? It gives us half pi r squared plus 16r pi minus 2r squared minus pi r squared. So that gives us 16 pi r minus 2r squared, and our half pi r squared minus pi r squared. They're both like terms. Half minus 1 is minus half. So minus half pi r squared. Question C. Find the exact radius of the semicircle for which the area of the window is to be a maximum. So in order for the area to be a maximum, we need to work out the first derivative and make it equal to 0. So if area is equal to 16 pi r minus 2r squared minus half pi r squared, and we want to find the area, the maximum area, we need to differentiate this. This gives us 16 pi minus 4r minus pi r. So maximum area is when that is equal to 0. 16 pi minus 4r minus pi r is equal to 0. We want to find the exact radius, so I want r by itself. So I'm going to move this to the other side. We've got 4r plus pi r is equal to 16 pi. Factorize out the r. And then divide both sides by 4 plus pi. And that's the exact radius. Now, let's just double check this. Make sure that this is correct. We just want to make sure that this is a maximum and not a minimum area. So what I'm going to do is I'm going to create a table of values for r and a dash. So we've got 16 pi on 4 plus pi. I know a dash will be 0 for that, so I'm just going to put that in there. Now, I'm just going to put this back into my normal mode, degree mode. So we have 16 pi over 4 plus pi. That's approximately equal to 7.038. So I'm just going to make this less than that and more than that. So I'll just say 7. So just say 7 and 8 for the radius. Okay, so what is a dash when the radius is 7? We have 16 pi minus 4 times 7 minus pi times 7. That gives us 0.27. That's stepping up. When it's 8, when the radius is 8, what do we get? Negative 6.9. That's sloping down, and so we can see that it is a maximum, right? That the area is a maximum. Okay, question D. Find the maximum area of this window correct in one decimal place. So, area, we need to work out, we actually worked that out before. Area is this. 16 pi r minus 2r squared minus half pi r squared. And the maximum area is when the radius is the 16 pi over 4 plus pi. Two lots of 16 pi over 4 plus pi squared minus half times pi times 16 pi over 4 plus pi squared. So let's put this in our calculator. So 16 pi over 4 plus pi. So we've got 16 pi times answer minus 2 lots of answer squared minus half times pi times answer squared. 176.9. 176.9. And the units for this, this is meters, so it's meters squared, square meters. And that's it.